Hi everybody, this is the last video we've got in the Module 6. It is the fourth section, Designing a Survey. So, Experimental Design and Ethics, this is 1.4 in that OpenStax introductory statistics book that we've been using. And it's got some good notes here. Purpose is to investigate the relationship between two variables. When one variable causes change in another, it's an explanatory variable. The affected variable is called the response variable. In a randomized experiment, the researcher manipulates values of the explanatory variable. They manipulate those, so they change maybe dosages, change strengths, and measures the resulting changes in the response variable. The different values of the explanatory variable are called treatments, and an experimental unit is a single object or individual to be measured. Blinding. I'm sure you've heard about a blind study. That definitely occurs, and that's what it says. When a participation study prompts a physical response, it's difficult to isolate the effects of the explanatory variable. To counter this a little bit, they set aside one treatment group known as a control group. This group is given a placebo treatment that cannot influence the response variable. The control group helps researchers balance the effects with the effects of the active treatments. If you know you are receiving a pill which contains no actual medication, then the power of suggestion is no longer a power. And you know that you're receiving which contains no actual medication, the power of suggestion is no longer a factor. However, I would say that you need it to be completely blind. Because if you know you're not getting any treatment, then you know you're not going to get any better. I think they were talking about the power of suggestion on people believing that they're getting better when they're not. When they blind them, though, it preserves, it saves you from being affected by the power of suggestion. You just don't know who's receiving the active treatment and who's receiving the placebo treatment. A double-blind experiment is one which the researchers don't know either. Because a lot of times researchers will get excited just like participants will get excited, and they may overstate the effects of the medication or whatever it is they're studying because they believe that's going to happen. If it's a double blind, the researchers don't know either. So it kind of makes it a completely clean experiment then. Okay. When you analyze data, it's important to be aware of sampling errors and non-sampling errors. Okay. The actual process causes some errors. It may not be large enough. Factors not related to the sampling process cause non-sampling errors. Okay? A defective counting device can cause a non-sampling error. In statistics, a sampling bias is created when a sample is collected from a population and some members of the population are not as likely to be chosen as others. When a sampling bias happens, it can skew your results so that you're telling people things that are true that are not true. Bias, a systematic error introduced by the sampling method. A sample has a bias when a part of the population is overrepresented or underrepresented. I know you heard about this during the election. You hear about it every time we have an election. And they start getting polls out and they'll start saying, well, they oversampled Democrats in this, so it tends to be that the Democrat's going to win. Or they oversampled Republicans in this case, and it tends to be that the Republicans are going to win. The actual thing in the actual population, you got about a third, a third, and a third. There's a third Republicans, a third Democrats, and a third independents. So if you really wanted it to be a good sample, you would need to have those same things representative in your sample. But if you pick 50% Republicans and 20% Democrats and then 30% independents, you're really skewing your results. So you want to make sure that you would pick a third, because that's how they pretty much lie in the regular population. A newspaper wants to find out what percent of the of the city population favors a property tax to raise money for local parks. A newspaper article on the tax increase invites readers to express their opinions on the newspaper's website. This is a self-selected because people just choose to respond if they want to. You would get some bias because, first of all, it would be people who choose to respond. And not everybody's going to choose to respond. Also depends on who visits the website. And also who uses the park. They may read it, may not even use the park, may not own any property that would get taxed. So definitely that would create some bias. Newspaper wants to find out what percent of the city population favors a property tax to raise money for local parks. In this case, the reporter interviews people leaving the city's largest park. Well, it's a convenience sample because they're convenient for the reporter. The problem is all these people are in the park already, so you know they use the park. You know they are interested in having the park. So there would definitely be a bias toward people liking the park. All right, in this one, a survey service calls every 50th listing from the local phone book. Well, this is systematic. There isn't really any bias unless there is some kind of link between people who are, he goes in the phone book and goes to people, businesses, calls every 50th business. Those people are paying property tax. So they might have some kind of bias on it. But if he stays just in the general alphabetized phone book, probably isn't much bias. Okay. The students planning the junior class party want to know what kind of pizzas to buy. They ask the pizza restaurant what kinds sell the most. Well, that's convenient. It certainly, is easy to get it. But the restaurant may not sell strictly to students. They might sell to families, single people, not students. So they may get an underrepresentation of students if you're trying to do it. Right? Critical evaluation. Okay. We need to evaluate the statistical studies critically and analyze them before accepting the results. There was an old saying, there are lies, and then there are dang lies, and then there's statistics. And that's because you can say pretty much what you want to and make it work if you're using statistics. So that's why we want you to critically analyze them. There's going to be more of that when you do Module 8. Common problems to be aware of. Problems with samples. A sample must be representative of the population. It's biased if it's not. Self-selected samples. If it's only by people who choose to respond, then they obviously have some kind of what they call a dog in the fight. They want to respond. Sample size issues. Samples that are too small may be unreliable. Larger samples are better. Some cases, having small samples is unavoidable. But, now I wouldn't say crash testing cars would be much because you actually can test the physical damage to the car. But, medical testing for rare conditions, if you've only got 1 out of 1 million people who get that disease, then you're going to kind of be stuck with what you got. There's not much choice. You can change that. Okay. Undue influence. Collecting data or asking questions in a way that influences the response. And you'll see that in sometimes when they make the question, definitely wanting you to answer in a particular way, or they don't give you any other choice. do you prefer this red car or this blue car? And when in actuality, you don't prefer either car, but they asked you specifically that red one or that blue one. That influences your decision. A non-response or refusal of subject to participate. The collected responses may no longer be representative of the population. Often people with strong positive or negative opinions will unduly influence. Causality. A relationship between the two variables does not mean that one causes the other to occur. They may be related because of their relationship through a different variable. All right, let's, it's been a little bit of time. We'll do the next one in a second.